Let's keep solving in this video. So we found out the effort levels, right, in this setting where they care about each other. Let's find the income level and then the utility as well. So the income level is going to be what? It's going to be a half, right? It's going to be a half of the total output. So this is what we're looking for right now. This is a half of the total output. Okay, and let's go over here below. 1/2 times P times beta. We will have that the income of one guy, which is the same as the income of the second guy, since this is all symmetrical, is going to be 1/2 multiplied with the price, multiplied with beta, multiplied with the effort levels added. And since the effort levels are symmetrical, we'll just have P times beta over theta multiplied by 2. Now let's solve the math over here. We have 2 and 2 cancel out. P times beta multiplied with P times beta, that's just going to be P square beta square divided by theta. Compare this with part C and with part B. So if you compare it with part C, where they didn't care about each other, their income level was only this one, a half of P square beta square over theta, meaning that when they care about each other, they double their income. So they double their income over here. And look at part B as well, where we had it over here. The income was the same effect, right? Caring about each other or maximizing team utility gives the same results. There it is. This is what the income used to be. We maximized team output, divided it by 2. This was the result, which is the same as P square beta square over theta. So we're just proving what we discussed in the previous video, as we expected. So hold on a second, I'm running out of space. Let me see where to go. Where was I? Yes. So the incomes, we found out the incomes. We proved that. Now let's also calculate the utilities. Let's also calculate the utilities over here. The utility of one guy, which is going to be the same as the utility of the other guy. Utility is going to be the difference between the income, the wage, and the wage is just P square beta square over theta. So we have P square beta square divided by theta minus the cost of effort, minus 1/2 theta, effort level to the power of 2. This is the effort level, P times beta over theta. So we have P square beta square over theta square. Let's work out the math real fast over here. Theta with theta goes away. So we subtract P square beta square over theta minus a half of that term. 1 minus a half is just a half, meaning that the utility is going to be equal to 1/2 times P square beta square divided by theta. Let's compare this with, again, part C and part B to prove the exact same thing, same logic. So the utility now is going to be greater than before because they care about the worker. And where was the utility before? The utility before was equal only to 3/8 times that term over here. This is what we compare with. Let me see if we can put, hold on, let me just zoom out to see everything. Yes. This we compare this to. You see, this was 3/8 times that term, P square beta square over theta. This is a half. A half is bigger than 3/8. So the utility is bigger now. And this is the same utility as we had in part B. Check this over here. The utility in part B, where they maximized team utility, used to be also 1/2 P square beta square over theta. Same result that we get. Now one last thing is to compare this. The utility of working in this setting where they care about each other relative to the utility of the individuals. I'm not going to write this all over again once more because we have it already. This is basically comparing the utility now, which we found out to be exactly the same as the team production, with the utility when they work individually, which we saw in part A, and we found out that beta must be greater than 1 for this setting, meaning that even when they only care about the total output, but they think about the other coworker, we get also at the same result as the team production when it comes to beta. Because of all the same thing, the synergy effect is big enough to incentivize them to work as a team when beta is greater than 1. So the highlight of part D is this. If the workers do not agree on the effort, but they care about each other, we'll get to the same results as maximizing team utility. So these are two ways to incentivize workers. That's what this whole personal economics is about. Incentivizing workers to make them happy, maximize their utility, but at the same time make enough money for the company. That's kind of the highlight. Hope this all makes sense, and we are done.